the sixth experiment of ANNDL lab, and here we are using a multi-layer perceptron model. The input will now be an image, and say the size of the image is 32 by 32, and you are trying to classify such images and trying to check the model for its accuracy. So the data set that I have used here could be anything. Context where I can use is in medical imagery, wherein you can even classify the MRI scans, you know. This is also one of the application where you could be using such model. So now coming to the problem statement, here I assume you can take any data set, but for your working, I have provided you a data set which has got different shapes like circle, squares and triangle. So the size of the image should be 32 by 32, and the categories are circle, square and triangle. Various shapes you will be using in training, and then finally you will be checking the accuracy if it is able to classify correct shape or not. So around 100 images you could take, and it will include a mix of triangles, squares and circles, and PNG images we are taking, and we are going to read that, pre-process it. Pre-processing could be like resizing the image. Sometimes, you know, the image could be of different size, so you could resize the image to be of same sizes, and sometimes you can also go for image augmentation techniques, and also you can use label encoder. So that could be the pre-processing hint that I can give you. Then what you're going to do is you're going to split your images into training data and testing data, and then you would be creating your uh, fully connected multi-layer perceptron. So here you could see that I am giving my input dimension, which should be equivalent to the train shape. See, I am passing image, so that image has to be first converted and as a vector, and then it will be given. So input dimension would be the shape of my training image, training data that I have given, and the activation function I am choosing here is ReLU, and for the hidden layer also I am choosing it as ReLU. And as you can see, for the output layer I have got 3 outputs. So obviously activation would be softmax. Now because it is categorical classification, I have to choose my loss function as sparse categorical cross entropy, and suitable optimizer. You can decide to choose any. I have chosen here Atom. You can choose any other, and also find out the accuracy what works for you, and also decide on the number of epochs, and also decide on the number of hidden layers. So this is just my model. You can create your own, and you can get more accurate data if you require. I have chosen number of epochs as 260 here. For me, for my particular model, I am getting an accuracy of say around approximately 67, 69. So I can actually try more to improve this model. Yes, so check how can I improve this model, check what other optimizers can I use, check about the number of epochs also. Sometimes if you overdo the epoch, then also it will be resulting in overfitting. So please work on all these criteria and submit me to a proper model with a better accuracy. So I leave it on you for this particular experiment.